to its original position when there is no current or voltage on it. The damping system are just gears that tells us about, these gears are installed on this section, that tells us about the speed of the rotation of this device. So it is actually a damping system that reduces the speed of its rotation and vibrating this needle. Shielding system on the other hand protects this whole system, so this is called shielding system. The operation of wattmeter is simple. These are some quantities that are dealt in this mathematical equation, so let's talk about them one by one. The voltage that is measured in RMS is given in here. The current to be measured in RMS is given by here, and we want I and V to be measured in RMS. Now IP is the current that is actually across this potential coil, this one. Why it is called potential coil? Because it is connected across the load. Now this RV is connected with this potential coil because this can be VP as well. Okay, this is connected in here because the resistance of this potential coil is very low. So if we have some current and here is a low path, so it will directly be grounded and this current would be affected. So for not allowing this current to be affected, we introduce an RV, and this RV is the external resistance that is connected with this pressure coil. RP is the resistance of this pressure coil plus this resistance of connected resistance with this pressure coil. Okay, IC is the current through this section of current coil. Theta is the deflection of a device that would be connected somewhere here, which will have this potential, this magnetic field from this and this, so this needle will deflect. It will be studied in the next section. Omega is the frequency of supply. So we are having AC components, each component would have some of its supply. So more supply frequency, there is more chances that this direction of current would change. Okay, phi is the angle lag between the I with respect to V. So phi is the actually the phase between I and V. So theta depends upon the IV cos of theta and this RP and mutual inductance of this coil with this rotating mechanism. So this is the operation of wattmeter, that how wattmeter operates. It operates when the current flows through this and the current flows through this. So this causes the amount of voltage based rotation to this needle, and this causes the amount of current based rotation, and this needle rotates, and hence we see a deflection theta, which is then calculated and rated. Okay, now first we'll study the phenomena of induction before moving to induction type instrument. The phenomena of induction states that if a wire is placed with an energized wire is placed, which is AC, with some closed loop, what it will do is that it will first induce some current in it, and then when this current produces some field flux, this same flux will interact with this flux and will try to rotate this flux. So it is just like that you first irritate this thing, and then when it gets angry, you use your force to check the reactance of this loop. So the live wire induces some magnetic field in the metal surface or another wire or core, then pushes the same magnetized region with its magnetic field, because the already induced magnetic field is in opposite direction to the light. Thus we can now know about an induction motor, that a motor in which the excitation is supplied to its one side and the rotation is observed on its electrically separated, this one is electrically separated side, but magnetically connected, so only fluxes are interacted. This is also known as rotating transformer. Magnetic induction motor is also known as the rotating transformer, because its one coil is stationary and the other coil is moving. So here if we see this example, this is our exciter side and this is our rotation. Here we will have some aluminium or copper wire which will have some current due to this flux induced by external sources, and then this will try to move because the flux of this current will interact with the flux of applying current. So induction motor and such instrument are also termed as rotating transformer because it's secondary coil. So this one is the secondary coil. Now let me color it in some other. This one is the secondary coil and it is a short circuit path which moves to compensate its short circuit current. So when current is induced in it, it produces magnetic field. So for avoiding this magnetic field to flow, this coil moves to some other place, so this flux is no longer then attacking on this coil. So it basically moves to another place where another flux again apply on it and again apply on it, so it rotates in circles. Now induction type instrument are such instrument in which we use induction. So we are having this one current, second current, and this is producing some current in this disc, and this disc will show some flux, and then that flux would again be imposed by this flux 2 or flux 1, and hence it will start moving just like the previous phenomenon. Just read this thing and you will understand. Okay, here are some equations. We are interested only in the first two equations. The first one states that the torque deflection would depend upon the phi. Phi is the flux and I is the current in it. So phi is the angle in it. Okay, so angle and current. So if the angle is at 90 degree, we will get more deflection. So it is always on 90 degree because there is a perpendicular plate of disc and it is just like acting in the center, and the amount of current would make more force in it. So it is depending upon the incident angle and flux, and the total torque deflection would be equal to this physical structure, frequency, and these angles. Cos theta is the amount of power that is used inside this disc. So it is basically the power factor or something. Just go through this reading in the book and you will know about it. Okay, what's the structure of this instrument? So this instrument basically rotates, so we can calculate its rotation as well. Okay, we are having voltage coil, current coil. So these are the current coils, and here would be having some voltage coil as well, aluminum disc which will be rotating. The rotation brakes, these are the brakes. These are basically magnets which makes this disc to be more attracted by these two terminals. So more attraction means less movement. Spindle with one gear. So this gear is actually a damping system and it is just like this. Okay, and the display display dial are mechanical dials, and these are connected to a watch like mechanism in which, let's say, one dial is like this and it has a wire, a metal gear, and here is another and it has another metal gear. So when this thing rotates one time, it will make this something to go a bit forward, and then second time a bit more forward, more, and its ratio is 1:10:100 or something. So this is the mechanical structure of these things. The section of energy meter consists of current and voltage coil, and moving disc. This is the moving disc, and the brakes. These are the brakes, and we are having registering components. So these are the mechanical counters in it. Operation is simple. We use some supply voltage, and this voltage causes some current to flow through this and some current to flow through this, and then connected with the load. So we are having two connections. One is for the potential connection and other is for the current connection. So two connections are done, and thus the torque is calculated by this frequency, the conduction, the angle of incidence, the resistances inside the coil, which will cause this torque to be a bit lower, and this angle of incidence. Okay, these are the fluxes actually. So more angle incident, more flux; less angle incident, less flux. This is the pressure coil and series current coil. Testing of energy meter can be done with the following conditions. Sometimes we use 5% of the rated current at unity power factor to test this energy meter, or sometimes 100% or even 120%. At one intermediate load with unity power factor, at 0.5 power factor lagging, and then we do the creeping test with voltage coils applied with 110% of the rated voltage, and then we check the starting test in which the current at 0.5% and full rated voltage is given to the disc before it starts rotating. So these are some tests. Just go through it and you will understand it. Okay, this is it. Thank you. Thanks for listening to this whole lecture.